Good morning, boys. Today we are continuing, we are following last lesson. We are going to use the probability spaces which we learned to draw last time to answer the questions presented. Remember that we use probability spaces when we have two events occurring at the same time. Now, I'm going to, like last time, I'm going to give you some examples which we are going to discuss and explain together. And then you will have homework uploaded on Clicks on this lesson. So, let's start with the first question. Two coins are tossed at the same time. Draw a possibility space. As we mentioned during the last lesson, since the two coins don't have any particular name, you can just name them first coin and second coin. You can put them wherever you like. You can put the first coin horizontal and the second coin sideways as I did, or you can flip them. The probabilities for the first coin are heads and tails. The second coin can also land either on a head or on a tail. So now that we've drew the table, now we are going to fill the table with all the possible outcomes. Mela, remember that we start always from the first coin now, wherever it is, and then follow it by the second coin. Mela, so we open the brackets. Here, the first coin landed on a head, so H, comma, and the second coin also landed on a head. In the box underneath, the first coin landed on a head, so open brackets, H, comma, but the second coin landed on a tail, so H, comma, T. In the second column, the first coin this time landed on a tail, so T, comma, but the second coin landed on a head, so T, comma, H. In the box underneath, the first coin landed on a tail, whereas the second coin landed on a tail as well. So we realize that we have 4 outcomes. Now we can go on to answer the questions. Find the probability that 2 tails are obtained. Now, 2 tails are obtained, okay? There are, from those 4 outcomes, there is only one outcome with 2 tails, which is this. I'm going to mark it with a very good, all right, or you can use another sign, all right? So I have only one outcome out of a total of 4. The probability that 2 tails are obtained is only one outcome from a total of 4. We are looking at the table, but at the same time using the formula to find the probability that an event occurs. And you write it like this. Probability that the event occurs, probability 2 tails is equal to 1, because there is only one outcome with 2 tails, out of a total of 4, because there are 4 outcomes in all. That's 1/4. It cannot be simplified further, so you leave it as 1/4. That's the first one. Now, the second question. At least one head is obtained. Find the probability that at least one head is obtained. Now, the phrase at least means one or more. Wherever you find an outcome with one head, that is considered correct. It is considered as a good outcome. When you have more than one head in an outcome, it is considered good as well because it at least means one or more. So let's write it down. Now this means one or more. So let's mark them. I'm going to use a different color now so to recognize them. At least one head, H, H, because you have more than one, it's correct. And I'm going to use the green marker. In the box underneath where you have one H, one head, it's correct as well. On the other side, in the other column, T, H, where you have one head, it's correct. Okay, T, T obviously is not correct because there you don't have any heads, all right? You only have two tails. So, our answer is like this. Probability at least one head, I'm going to write it in short, 1H, is equal to, there are three outcomes which are considered correct, 3 out of a total of 4. So the answer is 3/4. 3 out of a total of 4. Okay. Now, it cannot be simplified further, so that is our answer. Now, let's continue to number 2. Now we have a bigger probability space because we have two ordinary six-sided dice, and the question is, two ordinary six-sided dice are thrown. Question A, draw a probability space. Now, the dice don't have any particular name, so you can either label them as first dice, second dice, or dice 1 and dice 2. You can put them wherever you like, either horizontal or vertical. Okay, I labeled the first dice, I put it horizontally, whereas the second dice I put it sideways, but you can flip them. The important thing is that you always start from the first dice and follow it with the second, wherever it is. Okay, so let's start filling up our probability space. In the first column, I'm starting with the columns because there is my first dice. The first one under the column of 1, mela, from the first dice landed on a 1, whereas the second landed on a 1 as well. In the box underneath, the first dice landed on a 1, whereas the second landed on a 2. Then the first landed on a 1, the second landed on a 3. Then the first landed on a 1, whereas the second landed on a 4. The first landed on a 1, whereas the second landed on a 5. The first landed on a 1, whereas the second landed on a 6. That's the first column, ready? The second column now. In the second column, the first dice landed on a 2. So our first box should be 2, 1, because the second dice landed on a 1. The box underneath, 2, 2. In the box underneath, 2, 3. Then there is 2, 4. Underneath it, 2, 5. Underneath that, 2, 6. The column of 2 is ready. Now the column of 3, the first dice here landed on a 3, so the outcomes here in this column should start with a 3, so the first one 3, and the second dice landed on a 1, so 3, 1. The second one 3, 2. The third one 3, 3. The fourth one 3, 4. The fifth one 3, 5. The sixth 3, 6. Now, the column of 4, where the first dice landed on a 4, the first box would be 4, 1, because the second dice landed on a 1. Then 4, 2, 4, 3, 4, 4, 4, 5, and then last 4, 6. The column of 5 where the first dice landed on a 5. In the first box, the second dice landed on a 1, so it's 5, 1. And then 5, 2. And then 5, 3. And then 5, 4. And then 5, 5. And then 5, 6. The last column, the first dice landed on a 6, so it's 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. And we filled up all the probability space. Now, we can realize that we mentioned during the last lesson that we have 36 probabilities in all. 6 times 6, 6 by 6, it's 36. The first question is, find the probability that at least, here it is again, at least 1 5 is obtained. Remember that as we said, at least means one or more. So let's underline it to remember it, or highlight it to remember it. At least 1 5. Okay, so let's mark where we have at least 1 5, one or more. Mela, let's use a particular color. Mela, at least 1 5. Mela, 1, 5 it's correct. 2, 5 it's correct. 3, 5 it's correct. 4, 5 it's correct. All the column of 5, so 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, and last of all 6, 5. Now let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have 11 out of a total of 36. So the probability that I obtain at least 1 5, Mela, probability at least 1 5, 1 5, one 5 is equal to 11 all over 36. It cannot be simplified further, so we stop there. Okay, now the next question, a double is obtained. Now a double means from the first dice a particular number is obtained, and from the second dice that same particular number is obtained, like 1, 1, 2, 2, 3, 3, and so on. Okay, so let's mark them. We choose another color now. Mela, we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. If we count them, we obtain 1, 2, 3, 4, 5, 6. 6 out of a total of 36. Mela, probability a double is equal to 6 on 36. Now boys, this can be simplified, so you continue with, it can be simplified with 6. 6 into 6 goes 1, 6 into 36 goes 6. So the answer, the simplified answer is 1/6. Now, the last question is a total score of 4. Now that means a total score of 4 that you need to add total plus. you need to add the two scores. That means the score from the first dice and the score from the second dice. And wherever a total score of 4 is obtained, then that outcome is correct, okay? Let's count them. Let's mark them first and then count them. So, a total score of formula, we have 1, 3, because 1 plus 3 make 4. We have 2, 2, because 2 and 2 make 4. We have 3 and 1. We have, those are the only 3 outcomes that when you add the two scores, they add up to 4. We have 3 out of a total of 36. So let's write our answer. So probability a total of 4 is equal to 3 over 36. It can be simplified further with, I can cancel with 3. So the answer is equal to 1/12. Okay, so that's number 2. Now, number 3. This is a bit different. You realize why? Because in the following example, you don't write the two scores. You have to find the total of the two scores and write that total down in the probability space. Okay, so we are given this question. Imagine you have 2 6-sided dice. So it's similar to the previous, but you don't write down the two scores. You roll both of them together and add up the scores. If I were you, I would, with a highlighter, I would underline that. Okay? I would underline that. To remember that we have to add up the scores. The table below is a sample space diagram, a possibility space, for the outcomes of rolling the 2 dice. The first question, we have the sample space ready and we are asked to complete the sample space diagram, filling in the total scores for each possibility. So in that sense, it is a bit easier. We have the first few ready, so we need to complete them. 1 plus 1, that's why in the first column there is a 2. 2 plus 1. 1 from the first dice, 2 from the second, that make a total of 3. 1 from the first dice and 3 from the second, that makes a total of 4. If we continue, 1 from the first dice and 4, that makes a total of 5. That's a 5. 1 from the first dice, 5 from the second, that makes a total of 6. 1 from the first and 6 from the second, that makes a total of 7. So the first column is ready. 2 from the next column, 2 from the first dice, 1 from the second, that's a total of 3. Beneath it, 2 plus 2 make 4. 2 plus 3 make 5. 2 plus 4 equals 6. 2 plus 5 equals 7. 2 plus 6 from the second dice makes 8. The third column, 3 from the first dice, 1 from the second, makes a total of 4. 3 and 2 make a total of 5. 3 and 3 make a total of 6. 3 and 4 make a total of 7. 3 and 5 make a total of 8. 3 and 6 make a total of 9. The next column, 4 and 1, make a total of 5. 4 plus 2, 6. 4 plus 3, 7. 4 plus 4, 8. 4 plus 5, 9. 4 plus 6, 10. 5 plus 1, the next column, the column of 5. 5 plus 1, 6. 5 plus 2, 5 plus 2, 7. 5 plus 3, 8. 5 plus 4, 9, 5 plus 5, 10, 5 plus 6, 11. Now, the last column, the column of 6, 6 plus 1, 7, 6 plus 2, 8, 6 plus 3, 9, 6 plus 4, 10, 6 plus 5, 11, 6 plus 6, 12. And with that, we have completed the sample space. Now we need to answer the following questions. Find the probabilities of these events. S means total scores, total score. So the first question is probability that S, that means the total score, is 2. The total score is 2. I have only 1, as you can see, only 1. So it's 1 out of a total, as you can see, when you have 2 dice, 2 6-sided dice, 6 by 6 is 36. So the answer to the first one is probability a total score of 2 is equal to 1 out of 36. Now, probability that the total score is 4. Let's mark them now because we have more than 1. I have 4, I have 4, and I have 4 here. That's 3 out of 36. So, probability 4 is equal to 3 out of 36. Which can be cancelled with 3 itself, and it becomes equal to 1/12. Now, probability that S, the total score, is greater than 5. Let's mark them. Let's use another color. Greater than 5. The 5 is not included here because it says greater than 5. Okay, the 5 is not included. So, choose another color. Mela. We have the 6, all the 6s. We have all the 7s. We have all the 8s. We have all the 9s. We have all the 10s, the 11s, and the 12s. If we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. To check, you continue with the rest. We did not mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 26 and 10 make the total of 36, so we're right. So probability, we write it down, probability greater than 5 is equal to 26 on 36. Remember that it can be cancelled with 2, so it becomes 13 all over 18. Probability the total score is less than 7. Let's use another color. Mela, less than 7. It's important. 7 is not included. Okay, let's use the red now. Less than 7. Okay, I have the 6. I have the 5s. I have the 4s. I have the 3s. And I have the 2. If we count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's 15 out of a total of 36. So let's write it down. Mela, probability less than 7. It's 16. Let's check again. Let's check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, sorry, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 15 on 36. 15 on 36. It can be simplified with the 3. 15 division by 3, it's 5. 15 division by 3, it's 5. 36 division by 3, it's 12, so it's 5/12. 7 or less, we have to include the 7 now. We have to include the 7 now. 7 or less. We have to include the 7. So, we have, let's mark them with a yellow. The same red ones we can say, but we include now the 7 as well. We have all the 5s. We have all the 6s. We have all the 7s. Now we have to count the yellow ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 on 36. So our answer, and I'm going to write it like this, probability less or equal to 7 is equal to 21 on 36. It can be cancelled with 3 as well. 3 into 21 goes 7. 3 into 36 goes 12. Okay. Probability S is a multiple of 5. Now I'm going to mark them differently, and I'm going to try to mark them with a circle. A multiple of 5. A multiple of 5, I have all the 5s, 1, 2, 3, 4, and all the 10s, 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7. 7 on 36. Probability multiple of 5 is equal to 7 on 36. It cannot be simplified, so we'll leave it like that. Okay, S is a factor of 10. Now, factors of 10, I have, let's mark them with a red circle. I have the 2, which is a factor of 10. I have all the 5s. Okay. Oops, daisy. I have all the 5s. One, two, so up till now I have 1, 2, 3, 4, 5, and the factor of 10, the 10 is also a factor of 10. So in all I have 5 and 3, 8, 8. 8 on 36. So probability factor of 10 is equal to 8 on 36. It can be simplified with 4. 4 into 8 goes 2. It can be simplified with the 8 itself. 8 into 8 goes 1, and 8 into 36, it can be simplified with 4. 4 into 8 goes 2, 4 into 36 goes 9, which is equal then to 2 9s. 2 9s. Now, we have the fact that the next question, question H, S is a prime number. Now, the prime numbers that we have are, remember that as a prime number, we have those which have only two factors, themselves and 1. So, I'm going to mark them with green. Prime numbers. 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 7, and 11 is a prime number as well. Let's count them, all the green crosses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 on 36. 15 on 36. Probability prime 15 on 36, which can be simplified with the 3. 3 into 15 goes 5. 3 into 36 goes 12. Probability S is a square number. Square numbers we have, all the square numbers that we have here are the 4 and the 9. So let's mark them. Let's mark them with a highlighter now. The 4s, 1, 2, 3, and the 9s, 4, 5, 6, 7. 7 on 36 then. Probability square, we said it is 7 on 36. 7 on 36. Now that cannot be simplified further. Now boys, the next question, question 4, is for you to do on a separate piece of paper and upload it on Qlix. I'm going to point out one thing, that now in number 4, it is written in bold and underlined, the scores are multiplied together. Now in number 4, we're not writing down the total or the two scores, but the product, the answer of the multiplication. Remember that, because that is very important, okay? Apart from this homework, apart from drawing the sample space and answering the question, I have uploaded on Qlix also a worksheet which you need to do and upload it on Qlix again so that I can see your homework. Okay, that's all for today now, boys.